All right, number six. Number six. If there are more than one substituent, their positions and names must all be included. All right. Now look at that question. Now you have two substituents. You have two methyl groups attached to the second carbon atom. So what do you have? One, two. Okay. That will be two, two, each of them one by one. Two for the first methyl group, two for the second methyl group. So you have two, two. Since they are the same, methyl, they are the same. Double. So you have two, two, di. Di means two. Tri means three. All right. Dimethyl pentane. Okay. Two, two dimethyl pentane. The longest straight carbon chain is C5 pentane. All right. Two, two dimethyl pentane. Look at the next one. You have three methyl groups. All right. Attached. Okay. Now, if I go from front to back, I'll be having two, three, three. That is three, three for the two methyl groups bonded to the carbon atoms. All right, and two to the methyl group bonded to the second carbon atom. Now, but if I go from back to front, I'll be having one, two, three, four. Can you see? I'll be having three, three, four. Can you see? That is the bigger number you have there compared to two, three, three. That's the reason why we picked two, three, three. Okay, so we're going to be having two ascending order. Two, first of all, we will not say three, three, two. No, two, arrange it properly. Two, then three, three trimethyl rather. Sorry, we have three methyl groups, so we'll be having two, three, three trimethyl pentane. Trimethyl pentane. Now look at demonstrable examples on alkane. Demonstrable examples on alkane. Look at the first compound. Now, what if you are given the compound in this straight form? How do you name it? You need to draw it structurally. That will help you. That will help you. I've talked about structural formula, isomerism, and all that. We've done that in the previous classes. Draw it structurally. CH3 first. Okay, then CH. The H can be down and the CH3 up, no problem. A single bond. Okay, so you have CH3, CH bonded to CH3, CH bonded to CH3, then CH2 and CH3. Or you draw it the other way. All right, so then we'll name. Okay, we'll name. Okay, so how do we name? If we go from front to the back, we'll be having one, two, three. Two, three will be on the attachments. Two, three. If we go from back to front, we'll be having one, two, three, four. Three, four. So two, three is smaller than three, four. So we'll go with two, three, the front to the back arrangement. So we'll be having two, three. We have two methyl groups, dimethyl pentane. Two, three dimethyl pentane. Okay, look at number two, C. Then you have CH3 and bracket, then you have four. That means you have four CH3. How do you draw this one? Very simple. You draw your carbon atom, then you bond the CH3 groups to the carbon atom since they are four in number. How do we name this? Now look at this. We don't have four attachments. Don't be confused. We only have two attachments. For every alkane group, the beginning and the ending must always be a CH3 group. The beginning and the end must always be a CH3 group. So how do we name this? We only have two attachments, not four. So you don't say 1, 1, 2, 2, polymethyl, all right? Polymethyl propane, no, that will be wrong. We have only two alkyl groups, all right? That's CH3, CH3. If we go from front to back, that they will take number two. If you go from back to front, they will also take number two. So you have 2, 2 dimethyl propane, 2, 2 dimethyl, two methyl groups, dimethyl propane. Number three, the same thing, 2 methyl butane. Can you see? If you go from front to back, you have two on the attachment. If you go from back to front, you have three. Two is smaller than three. All right. So we have 2 methyl butane. The fourth one, you have 2, 2 dimethyl butane. Hydrogen is not an attachment. Don't forget, attachments are mostly alkyl groups having the general formula CnH2n plus 1. Number 5. Now look at number 5. Now I have two different attachments. I have a chloro group and yes, a chloro group and halo group, right? A chloro group is an example of an halo group, right? I have a chloro group and a methyl group. Which one will I name first? Always name. I think there's a rule that says you name them You name the halogens first. You name the halogen attachment first. So we're going to be having 2-chloro. They are both on the same carbon atoms. If I go from front to back, I have 2. If I go from back to front, I have 3. So we'll pick 2 as the lowest, as the lower number rather. So we have 2-chloro, okay, 2-methyl. They are different. Can you see? So you have 2-chloro, 2-methyl, then the longest carbon chain, C4. Butane, all right, 2-chloro, 2-methyl butane. Then number 6, you have 1, 2, 3, 4. If I go front to back, I have 2, 3. If I go from back to front, I have 2, 3. Can you see? All right, so we have 2, 3 dichlorobutane, 2, 3 dichlorobutane.